All right, let's give this another try. Redox number. So a redox reaction, as we have learned before, is a reaction where the electron is transferred from one reactant to another reactant. So before we get into how to use the oxidation numbers, which we'll do lately, we should get to know what oxidation and reductions are. Now, to put it simple in a nutshell, oxidation is when there is an increase in oxidation number. And reduction is when there is a reduction in oxidation number. Now, this is pretty simple, but how do we know which one is which without using the example of oxidation number to explain? Well, reduction is the adding of electrons. So, electrons. And oxidation is the minusing of electrons. Since an electron is negative, when there is more electrons, a reactant is more negative than it was before. Now, the same thing works both ways. When there's less electrons, the reactant is going to be more positive because there's less negative. Okay. The next thing we're going to learn is to use oxidation numbers and arrows to show that the following equations are redox reactions. Now, remember there are two parts to these questions. Usually you're given my bad. Usually you're given a chemical equation. Sometimes it may look much harder than this, and sometimes it's just merely possible. So you have to take your time with these and follow the rule. Okay, I'll be using a very basic, the first question slash example in the book to explain this concept. Now, there is a rule on how to decide the oxidation number. See, you don't calculate the oxidation number in this case. You actually follow a rule book. Right? You go through this rule book in its order and you figure out which one is which. Okay. Now, you can think of oxidation numbers as electrons, but they're not really the same thing. So keep that in mind. How do we know the oxidation number of any of these? You look at the rule book. So the first rule, there are four rules. You check whether there are any group 1 and 2 elements in here. And then you look at F, the element H or the element O. So is magnesium a group 1 or 2 um, element? That doesn't matter in this case because um, when you have one uh, single isolated element by itself, so when it's by itself, no matter how many numbers is in front, this element is going to be zero. Its oxidation number is going to be zero because it has to stay balanced. Same thing with O here. This is zero. But when you put them together, what happens? You look at this, and since there are two MgO, you check the rulebook. Let me check the rulebook. I mean the periodic table. Okay, now magnesium is a group 1 or 2 element, so it's gonna have its original charge, so which is 2 plus. Now when there is 2 times 2 plus, that becomes 4 plus. So what does oxygen need to have? Well, in this case, it just has its original charge, which is 2 minus. Now this balances out to be 0 overall. So that's a pretty simple example. Now remember, the rules are group 1 and 2, and then F, H, and O. So these are in the order of how elements should keep their original charge, and the rest you just do what I did. Fill in the charge of the known elements, and then do some math. That's pretty simple, and redox is actually Probably the easiest topic I find. You just follow a rule book. It's simple enough.